let's graph f of x, and then graph its inverse and determine if the inverse is a function. So here's what we're going to do. First of all, the graph of f of x is just the graph of x squared moved up 2, right? So instead of starting at 0, 0, it's going to start at 0, 2, and then it's going to go up 1, up 4,
so this is also 45,
up 1,
and this is also 45, and then this.
So there's my graph.
Does that make sense?
That makes sense.
Now, here's how you graph an
down
inverse.
And say it again?
The way that you graph an inverse.
I will draw it on a piece of paper so I'm not writing all over your problem.
Is you take the line y equals x,
Okay, so
which is right there. That yellow line is y equals x, and each point gets reflected over that line. So I'm going to graph the inverse in red. So f inverse of x, I switch the x and the y around. So instead of this point being here, which was
so you have two supposedly
purple graph was 0, 2. Let's just label all these points. 0, 2, 1, 3, 2, 2 squared, 4, 2, 6.
Take those points.
You can pick whatever points you want. But you want to pick points that give you a good picture of what the graph's going to look like.
So this
Negative 2, 6. Okay, those are my 5 points. Now, if 0, 2 is a point on my purple graph,
and
then on my red graph, 2, 0 is going to be a point.
What does A have to be?
That point right there is reflected. That's reflected over that line.
A has to be.
If 1, 3 is a point on my purple graph, then 3, 1 is a point on my other graph. It's reflected over that line.
3, 1.
3, 1 is reflected of 1, 3.
That's
so if you have 45 here.
Sorry, 3, 1. Thank you.
This has to.
3, 1. Good point.
I got you.
You caught me. Good. 3, 1 is right there.
So that means this.
It's reflected. See how it's reflected? If 2, 6 is on the purple graph, then 6, 2. 3, 4, 5, 6, 2 is on that graph. See how it's reflected? Those are reflected. Now this grid might not be exactly square, so it might look not like a perfect reflection, but you get the idea. If negative 1, 3 is on my purple graph, then 3, negative 1, that's what I was getting at before, is on my other graph.
That's why it's 90 and 90.
And if negative 2, 6 is, then 6, negative 2 is. You see how I've reflected all those points?
So then.
And so there is my.
You can also look at
that one's a lot easier than this.
So you see.
That is my reflected graph. And is it a function?
And then these are two angles
is f inverse of x a function?
Yes.
No, it's not.
This has to
Why is it not a function?
To equal 180.
Because it doesn't pass the vertical line test.
45.
Here's a point where they have the same x value and two different y values.
And then again, you just look at this line.
So that's how you do those problems. Now this was an easy one. When they give you something like x cubed or something, that's trickier because the graph looks a little bit different. But let's take a look at that. If we're doing x cubed, let's say we want to do the same problem. X cubed plus 2.
But then you have to figure out what's over here too.
F of x equals x cubed plus 2. That's a little bit of a different problem.
Let's see.
Because
I don't remember how
it's harder to see what that looks like when it flips over.
But
and it's harder to find points, a little harder to find points, but I'll do this kind of quick for you. Basically, you're going to take this graph and you're going to move it up 2, and it's going to look like this, something like that roughly. Take your line y equals x.
There's not really a good way to explain it. It just, it's one of those things.
And now,
actually, as you get into the lesson, you'll learn that A and D
the x and the y and flip it. So this point right here, which was 0, 2, becomes 2, 0.
So
this point right, let's just pick any point. Let's just pick some points. 1, comma 3, 2, comma.
Just math.
Sorry, I should be doing this in a different
color.
color.
And then if you notice, these are across from each other and they're the same thing. And these are across from each other, so they're the same thing. So you can do that with all of them. So
points on f of x are 1, comma 3.
This has to be 45.
Of course, 0, comma 2 is a point. 1, comma 3. I'm just plugging them in like a T-chart. 2, plug in 2 here, and what do you get? 2 cubed is 8, plus 2 is 10. Now let's plug in
Yeah,
negative
so you're
1.
right with this, where this
Negative
is
1 cubed is negative 1 plus 2
because
is
120 plus
1.
60 equals
Negative
180.
2 cubed is negative
And
8
it's the same
plus
thing
2
up
is
here.
negative
11 plus
6.
this angle
You want to
would
pick
equal
some
180.
points, at least a couple points on both sides of this center point right there.
Yes.
So my points were 1, 3. There's 1, 3.
And then that's
2,
gonna be
10 is
60.
like way up there, so this is actually steeper. I should have drawn this a little bit steeper. Because it's going to, up here you're going to have 2 comma 10.
So yeah, hopefully that helps.
Right here you're going to have negative 1 comma 1. So that point, negative 1 comma 1 is on my graph like that. And then this is more steep down here. Negative 2, negative 6. Negative 2, negative 6 is somewhere down there, is on my graph. Okay? So here are my points. 210 I wrote, 1, 3 is there, 0, 2 is there, negative 1, 1 is right there, and negative 2, negative 6. Now if I take each one of those points, I'm going to turn to red now. The inverse function, I flip each one of these over the line y equals x. 1, 3 becomes 3, 1. It's right there. 2, 10 becomes 10 out here somewhere, 2, somewhere out there. I might be at 9, 2, 9, but somewhere like that, right?
Sure.
Sorry, 9. So that point should be 10, 2 because I flipped it. See how it's flipped over that line? If I go equidistant. This point right here, negative 1, 1 becomes 1, negative 1. This point here, negative 2, negative 6 becomes negative 6, 1, 2, 3, 4, 5, 6, negative 2, right there. Can you see what's happening?
Yeah.
Can you see your picture?
Yeah.
That's why you have to have a sufficient number of points to be able to draw your graph. So this is what your graph does. See how I flipped that green graph over the line y equals x?
Yeah.
That's what I did. And that is a function. That is a function because it passes the vertical line. And that, my friends, is how you deal with graphing functions and their inverses to determine if the inverses are functions.